Now in learning objective B, we're going to write the equation if we're given either the translation rule or a picture of the image. In this one here, what they've told us is we have our parent function of the cosine of x. What they want to do is find the equation if we did this translation rule to it. Now keep in mind, in words, what's going to happen. It's going to move right pi and down 2. So let's go ahead and first identify the key points. The parent function here is y equals the cosine of x. Now the image I can actually write. If I have the ordered pair, it's not too bad. Let's just take the parent. And to the x, I'm not going to add pi, but I'm going to subtract pi. And I need to put parentheses around that so I know it's with the x. And with the y, I'm just going to go ahead and do minus 2 right here. Now I could have, again, went backwards and did plus 2 right here, and then cleaned it up by subtracting 2 from both sides, and it would move on over here on this side. So I have the image. Now let's be careful on here. They want to know the amplitude and the period. This is actually kind of a trick question. Remember, the amplitude is the hump of this, and the period is the horizontal length. So let me just sketch for you really quick the parent and what this looks like. So there's a rough sketch of the parent, and now the new image would be what we see here in the green is the image. So be careful when they ask the amplitude and the period. When we shifted this guy, we just took the red graph and we slid it on the graph paper. We didn't stretch it. So its period now here is from 1 pi to 3 pi. Well, the period is still 2 pi, just like the original parent function. Again, amplitude on here is how tall each little hump is. Well, the amplitude of the parent is 1. Or remember, to find amplitude, take max minus the min and divide by 2. So 1 minus -1 is 2, divided by 2 is 1. Well, double check the amplitude here. Here I'm at -1, here I'm at -3. So if you do -1 minus -3, that's still 2. Divide that by 2, the amplitude is still 1. So they're trying to trick you because amplitude and period are only impacted by stretches, not by doing any translations. So be very careful with that. Okay, let's go to this example. Here they've given us the graph, and we have to write the equation. So unlike the last one, we don't have the translation rule. So what I want to do is figure out what we're looking at, and they said it's the cosine function. So I'm going to write down the parent, and I'm going to go over to this graph paper and actually sketch one cycle of the parent. So our C shape goes from here to here, down at 1, and cuts right here. So if we connect the dots, we're going to get something like that. Now, let's see how it slid. Easiest way to do it is to take an existing ordered pair. Right here is the ordered pair 0, 1. And to find that same ordered pair on the new image. Well, if I trace out the same shape here, notice the top of the C, and I come back to the top. The identical shape would be right here. Okay, we have to mimic it exactly. So the starting point for this point actually moved right over here. Well, this ordered pair is -pi/4 and 0. So how did it change? Well, what they did is it looked like they moved back pi/4 and down 1. Can you make the translation rule for that? Sure. Again, we said here they went backwards pi/4, so they literally said x minus pi/4. And then from here they dropped it 1, so y minus 1. Everything is flowing together. The ordered pair rule is the same as the picture. It's just the equation that's going to be backwards. So now all we have to do is we're going to go backwards into the equation for the x. So to write this, y equals the cosine of x plus pi/4, and then we'll do minus 1. And that would be the equation of this graph. Now let's look at one more here. You can either write this one as a sine or cosine function, because all they said is they want a sine function. They didn't say sin or cos. I'm going to show you how you can write both of them. First thing I want to do, though, is add one more point to here. And I'm going to identify this ordered pair right here. I'm going to tell you this is pi/6 and 3. So jot that down. Okay, let's first write it. What if we think it's the sine? Easiest way to do this is to first just sketch the parent function of sine. So the S shape from 0 to 2 maxes out at 1 and bottoms out there. Now, what you want to do is try to mimic the same shape. So the parent function has one top hump and then a bottom. They're equally balanced. Where do you see that happening in here? I actually see it from here to here. So I'm going to use a different color and just highlight that. There's the top and there's the bottom. Now, what you need to do is just see how did the starting point here change to here. If you travel from the one point to the other, it looks like they're going to go right a little bit and then up. Okay, how far right did they go? Well, this initial ordered pair right there, by the way, is 0, 0. So it went from 0, 0 to pi over 6, 3. So they went right pi over 6, and then they went up 3 units. So the translation rule for this, as the ordered pairs, is x plus pi over 6, y plus 3. Now remember, everything flows. The ordered pair rule, the graph, it's just the equation that's going to be backwards. So to write this, all I'm going to do is take my parent function, and for the x I have to go backwards, so I'm going to minus pi over 6, and then at the end just plus 3. So this would be the correct equation if I wrote it as sine. Now what if I wanted to do cosine? So the parent is the cosine of x. Let's go mimic its parent really quick from here to here and do a sketch. So there's the cosine. Now I need to do the same thing. I want to mimic that same shape somewhere on this graph. Now notice it's a C shape, so it starts high, we go this way, and we end high. So my eyes go right here. Why don't I start, and there's one complete cycle of the cosine. Well, how did it change? Well, this ordered pair looks like it is 0, 1. So here's how it changed. They took here, they went right some amount and went up 4. Well, the x used to be at 0, but now they went to 2/3 of a pi. So they moved over right 2/3 of a pi. So let me write that down as an ordered pair rule. Okay, so right 2/3 of a pi. So right 2/3 of a pi. Now they were at 1, but now they're up at 4, so they actually went up an additional 3. So if we put this into the cosine function, we're going to do the cosine. We're going to do x minus 2 pi over 3, close it out, and then do plus 3. And this is the equation for cosine. Now the key thing here to realize is you're going to notice that the vertical movement is plus 3 on both, and that makes sense. But remember, sine can become cosine and vice versa with a phase shift of pi over 2. So if you take this graph and you do a phase shift of pi over 2, which would be subtract pi over 2 from this value, you would actually get this right here. So they are the same graphs.